Hello everyone, Jai Hind to all. Welcome in digital studio of Ajay Kumar Garg Engineering College, Ghaziabad. Today in this video lecture, I am going to discuss about sorting. First of all, in the outline, we saw what is the definition of sorting, the definition of sorting, types of sorting algorithm, what is the insertion sorting, characteristics of insertion sorting, algorithm of insertion sorting, working of insertion sorting, complexity of insertion sorting, and program of insertion sorting. First, the definition of sorting. The process of arranging the data in ascending or descending order is called sorting. I have an example. Here the element is 2, 1, 4 and 3. We want to sort in a particular order, which may be ascending or descending. According to our need, we have to sort the array in a ascending order or descending order. In case of ascending order, we have to take the first smallest element first, then next largest element, then largest element. In case of descending order, first we have to put largest element first, then we have to arrange accordingly. And the next is the types of sorting algorithm. The first one is insertion sort. This is the algorithm and simple algorithm which is used to sort the given data if the number of element is smaller. Now the second topic is selection sort, then bubble sort algorithm, merge sort algorithm, heap sort algorithm, and quick sort, radix sort algorithm. In different sorting algorithm, we have to use different types of method, and here we only discuss about the insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing card in your hands. The array is visually split into a sorted and an unsorted part. That means we have the given array, and that array the element is inserted in a order, but the order of the element is not in a ascending or descending. At that case, we have to use a insertion sort algorithm to sort the given element in a particular order, which is ascending or descending. The value from the unsorted part are picked and placed at the correct position in sorted part. That means we have to select an element from unsorted part and put the element into sorted part. Now the second step is repeated. The second element picked from unsorted part and put inside the sorted part, and so on. We have to sort the given array in a ascending or descending order. The next is the characteristics of insertion sort. The first is simple implementation. Simple implementation means this algorithm is easily implemented on any type of data structure, so it is just simple to implement. The second one is efficient for small sets. Means if the number of data is small, then we have to use insertion sort, which efficiency is high and complexity is less as compared to other sorting algorithm. The next point is adaptive. In equation, it is appropriate for data sets that are already substantially sorted. That means if the given data is already sorted in ascending or descending order, and then we have to apply the algorithm to sort the given element, then this gives more adaptive solution for the given input sets. So this is the three characteristics of the insertion sort: simple, efficient, and adaptive. The next topic is algorithm. This is the steps which is shows here to how the sort the given element in a particular order. The first step is, if the element is the first element, assume that it is already sorted, return 1. That means if the given array having one element, at that case we need to return the value as entered value, there is no need to call the given function for execution of sorting algorithm. The second step is pick the next element and store it separate in a key. That means from a inserted array, we have to pick second element and insert at the position which is sorted array are given. Now the third step is compare the key with all elements in the sorted array. After picking the key value, we have to compare the elements before the key value, and if the position is identified, then we have to insert the element at the proper position. Now the third is if the element in the sorted array is smaller than the current element, then move to the next element, else shift greater element in the array towards the right. If the given element is greater than the previous element, then we have to apply no swap case. If the picked element is less than the previous element, then we have to swap the value and compare the next to the next value, and so on. We have to repeat the process for sorting the given element. The step 5 is insert the value. That means after getting the correct position, we have to insert the given value at the proper position. And the last step is repeat until the array is sorted. This process is repeated continuously to sort the given elements in a ascending or descending order. Here the key is the element which is picked from the given list. That means the first element which is taken inside the key, then we have to compare one by one and sort in a particular order. Now the topic is working of insertion sort algorithm. How the insertion sort algorithm is work and how the steps is followed to sort a given number of elements in a ascending or descending order, we show here. The first is we have to take an example. We take an array. The elements of array is 12, 11, 13, 5 and 6. Now we want to sort this given element in a ascending order. For the ascending order, we take pass 1, and pass 1, initially the first two elements of the array are compared in insertion sort. First we have to take 12 and 11 and compare 12 and 11. If 12 is less than the second element, then there is no sorting. If the first element is greater than the second element, we have to swap the given element and compare the previous value. Here we have take 12, 11 and compare 11 with 12. That means key, the value of key is 11, and we have to compare the value of key with the previous value. If the key value is less than previous value, we have to swap the given value and insert at the proper position. Now the next step is 11 is less than 12. We have to swap. 11 comes here and 12 comes here. Now there is no previous element before the 11, so the 11 is inserted at this position. Next 11 is in the sorted array and this is unsorted array. Now we have to take next element. The next element is 13. 13 is the key element. Now compare with 12. If 12 is greater than 13, then we have to swap, otherwise no swapping. Here 13 is greater than 12, so there is no need to swap the value. Now third pass. In case of third pass, we have to take 5 is a key element and compare with 13. 5 is less than 13. We have to swap 5 with 13. The next element, the next sequence like this. 5 comes here and 13 goes here. Now 5 is the key element. 5 compare with 12, and 12 is also greater than 5. So we have to swap 5 with 12. The next sequence is 5, 11. Now 5 is also less than 11. So we have to swap 5 with 11. The sequence is 5, 11, 12, 13 and 6. Now the sorted array should be this, and this is the unsorted array. Now the next key value in the next pass we have taken 6. So 6 is the key value, and now compare with 6 with 13. 6 is less than 13. So we have to swap 6 with 13. The sequence is 5, 11, 12, 6 and 13. Now the key element is compare with 12. 6 is also less than 12. So we also next step we also swap 6 with 12. Now 6 is compare with 11. 6 is less than 11. We then swap the value 6 with 11. The sequence is 6 is the key element, and we compare with 5. 5 is less than 6. There is no swapping occur here. So we put this is the output of fourth pass. There is no change in the given sequence. Now this is, and we pick the last element as a key element. So there is no change in the given sequence, and this is the output of our given array. That means whenever we enter in a array, the sorted or unsorted, after getting the in form of the sorted, this is the ascending order sorted form. The first element is 5, then 6, then 11, then 12, then 13, and so on. We have to sort the given element in a ascending order. If we want to sort in a descending order, we use process just reverse. That means if the key element is greater than the previous element, then we have to swap the given element. Otherwise there is no swapping. That means if the key element is less than the previous element, there is no swapping occur. By using this process, we have to sort the given array in a descending order also. Now the next point is complexity. Complexity means how much time and how much space will taken by the given program to run a particular code. There are two types of complexity. The first one is time complexity, and second one is space complexity. In time complexity, we have to check how much time a program to take to execute the given code. Here we have discussed three types of time complexity. The first one is best case, second one is average case, and third one is worst case. In best case, the array must be in sorted order. That means if we have to calculating the best case, that means the given array is already sorted. That means if we run the algo on a order which is already sorted, then the best case time complexity is gives on. At the case of average, the array sorted and in unsorted parts. That means some elements is sorted and some elements is not sorted. At that case, the average case is arise. And in case of worst case, the element in reverse order. That means if we want to sort in a ascending order and the element is given in descending order, at that case worst case is arise. This is the part of time complexity. And the next one is space complexity. Space complexity is depend on input variable. That means how many number of input variable are required, this depend on space complexity. If the number of variable is 1, then the space complexity to be 1. If the number of variable is increases, then space complexity to be also increases. This is the two complexity of any programming. The first we discuss time complexity. Already discussed, time complexity depend upon number of times a program to be executed, any number of lines in a program to be execution. And the space complexity is depend on input size. What is the input size of a program? That means what is the input variable of a program that decide the space complexity. If the number of variable is increased, then space complexity also will be increased. Now the main program of the insertion sort. Here this is the first part in which we have to only insert the value of array. The value of array means if we want to insert 2, 4, 1 and 0, and this is the inserted value which is stored inside the array. And now we want to sort this inserted array in a ascending or descending order. Then the main logic is this. This logic is for sort the element in ascending order. We have to sorting the element in ascending order by using this logic. Because we take an example 2, 4, 0 and 3. We want to sort this given element in a ascending order, then we have to use this logic to sort the given element in a ascending order. If order to be changed, then the given logic will be also will be changed. Here we have to run a loop, start with I equal to 1, I less or equal n and I plus plus. We have to start the loop from I equal to 1 because in the given array there is no need to start with 0. This is the 0, this is the 1, this is the 2 and this is the 3. We first take 4 as a key element, and this key element is compared with the previous element, and if the key element is less than the previous element, we have to swap, otherwise no change. Here the next line is j equal to I. Initially we have to take a j equal to I equal to 1. That means we also assign the value of j equal to 1. Then we have take a while loop. The condition of while loop is j greater than 0 and j minus I is greater than aj, yani j. If this condition is true, then the temp equal to arrj equal to arrj minus 1, arrj minus 1 equal to temp j minus minus. This condition is for swapping. Swapping, I already tell you कि if the given elements, that means 2, 4, 3, here the next element is 3 and 3 is less than 4, then we have to swap 3 with 4. This condition, this steps executed here. And the last one is how the print the given sorted element in a particular order. Here we have to, we want to say how the given code is executed. At the initial condition I equal to 1, this is the steps where we assign I equal to 1, 1 less than the size of the array, and that would be 3. The condition is true. Now the pointer enter inside the loop and it take j equal to I equal to 1. Now the value assigned of j is 1. Now the while condition is executed. While j is greater than 0, yes, condition true, and a j minus 1, that is a 0 is greater than a 1. First you check the condition. A 0 means 2 and a 1 means 4. 2 is greater than 4? No. Condition is false. The next pointer is not enter inside the loop, because while condition is false. The pointer enter inside the loop if the both condition is true, otherwise the loop is active. Now the condition is false, so the value assigned value will be changed. Now the value of I equal to plus plus, that means the value of I is 2. 2 is less than 3, condition true. J equal to 2. Now again the same condition is checked. J is greater than 0. Yes, 2 is greater than 0, condition true. Then A1 is greater than A2. The value of A1 is 4 and the value of A3 is the value of A2 is 3. Yes, this condition is true. In the condition of true, the pointer enter inside the loop and it change the given value. First assign temp equal to AJA, that means temp hold 3, then AJ hold 4, then AJ minus hold 3. That means after executing this condition, the output of the array is 2, 3, 4 and 0. Here we have to taken the array is here the 0 and here is the 3. Now the next condition is the value of j should be decrement by 1. Now the value of j is equal to 1, then repeat the same condition. J is greater than 0, 1 is greater than 0 as condition is true, and j minus 1, that means A0 is greater than A1. The value of A0 is 2 and the value of A1 is 3. Condition is false. There is no swapping of the given code as it is. This code is printed. Next, the value of I is incremented again. Now the value of I equal to 3. J assign 3. 3 is greater than 0 and AJ minus 1, that means A2, the value of 3 minus 1, 2, the value of A2 is 4 and the value of A3 is 0. 4 is greater than 0, condition true. This perform the swap operation, 0 comes here and 4 goes here. Now the condition like this, 2, 3, 0 and 4. Now this is the key value. At that condition, the value of j is decremented by again 1 and the value is A1. A1 is greater than A2 as condition is true. Now again swap out, the here comes 0 and here goes 3. Then the array is 2, 0, 3 and 4. Now 0 is checked with 2, 0 less than 2 less than 0, that means 2 greater than 0, no, condition false. Again the value is swap out and the value is swap out and the output generated here is 0, 2, 3 and 4 and so on. This is sorted, and this sorted array is printed uh, uh, by using the printf function. If we want to sort the given element in a descending order, then this code, this condition will be changed. By changing this condition, we have to print the given element in a descending order, and this is code for use to print the given element in a ascending order. Here, in case of printing the output, we have to start the loop with I equal to 0, I less than n, and I plus plus, print f percentile d and I a I, and by using this we have to print the given array in a ascending order. By using these concepts, we have to sort the given element in a ascending or descending order. This is the logic for ascending order. If we want to print in a descending order, then we have to change the condition and we have to print in a descending order. This is the all about insertion sort. If any doubt or any query, please comment in comment box. Thank you so much.